Good evening, everyone, and good morning to Professor Richard Mayer, who is joining us from California. I'm delighted to open the second and final session of the 2026 Chase Pre-Conference. So thank you for those who have stayed with us from the first pre-conference session. My name is Dr. Noah Brandel. I'm a postdoctoral fellow at the Open University's Research Center for Innovation in Learning Technologies, and I serve as head of the Chase Conference Organizing Committee. We're honored to have Professor Mayer here with us as our keynote speaker. Professor Richard Mayer is Distinguished Professor of Psychological and Brain Sciences at the University of California, Santa Barbara. His work has shaped the fields of learning sciences and educational technology, and many of our own courses here at the Open University draw on his work. In his research, Professor Mayer applies the science of learning to education with a particular focus on multimedia learning, game-based learning, learning in virtual reality, and learning with animated pedagogical agents. He has received numerous prestigious awards for excellence in research, serves on the editorial boards of no less than 12 journals, mainly in educational psychology, and has authored over 600 publications, including 35 books. Professor Mayer will now deliver his keynote lecture entitled, "What Does the Evidence Say About Designing Multimedia Instruction for Meaningful Learning?" And before we begin, as in the previous keynote, if you have any questions during the talk, you're welcome to submit them via the chat, and they will be addressed at the end of the session. So, Richard, the floor is yours.
Well, thank you very much for that nice introduction, and I'm really pleased to be here with you this evening. Um, can everybody hear me okay? Perfect. Okay. Today, I really want to share with you, I guess I would call it my quest, um, to kind of understand how meaningful learning works. This is something I've been trying to understand for many decades, and I just want to share with you the progress that we've been making um, uh, on that topic. So I'm hoping to speak for just 45 minutes or so, and then I have questions after that. So greetings from Santa Barbara. This is where I hang out. Our campus is on the beach. It's and The psychology building is kind of in the more toward the right, a little about a half block up from the beach. Um, but uh, what I would like to share with you today is first just a brief introduction, then uh, a look at how meaningful learning works, and then I want to spend most of my time looking at evidence-based principles for designing effective multimedia instruction. So my general question, my general, I guess, domain here is applying the science of learning to education. And in order to do that, I have to understand how do people learn? So that's kind of the science of learning. How to help people learn, which is the science of instruction, and how to determine whether people have learned anything, which is the science of assessment. So some of these books on the left kind of focus on the science of learning, and the one in the middle on science of instruction, the one on the right, science of assessment. Um, this question of how can I help people learn so they can apply what they've learned to new situations? This is the question that pretty much has driven my research over the last, I'll say, 50 years. Um, it's a question that I started with in graduate school, but I'll say it has dogged me and driven my research for 50 years. So that gives me an excuse to show a picture of my dog here, Teddy. Um, there are a few different ways of trying to help people learn so that they can transfer to new situations. On the left are techniques for instructional methods. So, how we can design instruction to help people be able to transfer. That's what I want to talk to you about today, especially the lower left-hand corner that looks at instructional methods for multimedia learning. Another way to try and do this is to equip students with learning strategies so that they can be um, successful learners. So that's more on the right here. So today, like I said, we'll be looking mostly here on the work that's in the lower left-hand corner on instructional methods for designing effective multimedia learning that promotes transfer. Um, so first, let's look at a very brief overview of how meaningful learning works. This is a field that's been going on for more than 100 years, but I'll summarize it in 3 minutes. I might leave a few things out. Um, so how, just to remind you, my question here is, how can we help people learn so that they can use what they've learned in new situations? A very classic question, both in uh, of learning and also in education. Um, and if we can understand how to design instruction, then we can affect learning. And when we affect learning, we can detect that through our assessment, and our assessment can guide our instruction. So this little graphic is just trying to show the relationships among my three big topics here: instruction, learning, and assessment. So first, let's just look at the science of learning. Um, I mean, in a sentence, we could say meaningful learning is an act of knowledge construction, but we have to really understand, well, how exactly does that work? The classic definition of learning is that it is a change in what the learner knows that is caused by the learner's experience. So we need to create experiences that will help the learner change their knowledge. The three main cognitive processes that I've been focusing on, the three main processes that are involved in meaningful learning are selecting, organizing, and integrating. So, selecting means attending to the relevant information in a lesson. This is a place a lot of students have trouble just knowing what they should focus on, what's important, maintaining their focus. Organizing, this is mentally the important information in your working memory into some kind of coherent structure. And then integrating, this is connecting the incoming information with relevant prior knowledge that you activate from long-term memory. Just making sense? Okay. Um, Drawing on three main principles from the learning sciences, the idea of that people have separate channels for processing visual and verbal material. Um, We have limited capacity in each channel. The single most important contributions to the world. Is everybody hearing me okay?
Yeah, we hear you well.
Is it, um, so the idea of limited capacity is something we've known about since William than 100 years ago, but um, it is a crucial part of what instructional designers need to think about when they're designing instruction. Active processing, this is the idea that meaningful learning depends on the learner engaging in appropriate cognitive processing during learning, such as selecting, organizing, and integrating. So we have a kind of a structural problem here with we need to engage in a lot of processing. We have two, both of them are very limited in capacity. So we have to kind of design to take advantage of our cognitive architecture. This is kind of a graphic that tries to summarize that. Information comes in on the left side here through our ears, if the words are spoken, through our eyes, if the words are printed and the graphics are printed. Um, they enter our sensory memory where they decay rapidly, so we have to kind of pay attention and select out parts that we want to process. That's the selecting words, images, arrows. Then in working memory, we mentally organize those words into a verbal model, the images into a pictorial model. We try to integrate those with each other and with knowledge from long-term memory. So that's the integrating area. So um, we could talk more about this if during questions, I guess. Um, let's look. So that's kind of a view of maybe how meaningful learning works. Let's look at instruction. So instruction really is to guide the learner's cognitive processing during learning. And instruction basically is an attempt to mimic experiences with the intention to cause learning. So we're trying to cause a change in knowledge by providing the learner with certain experiences. During learning, three demands on our limited working memory capacity. Extraneous processing is cognitive processing that is just wasted, that's not really supporting the instructional objective, and it's just caused by poor instructional design. Unfortunately, we see a lot of examples of this. Essential processing, this is processing that's required to represent the presented information in your working memory, and that just depends on how complex the material is for the learner. Generative processing, this is deeper cognitive processing that's required to make sense of the presented material, try to relate it to your prior knowledge, reorganize it. This is caused by the learner's motivation to exert effort during learning. So this leaves us with three kind of top level goals in instructional design. We want to reduce extraneous processing, so that frees up capacity for the good kinds of processing. We want to manage essential processing because if the lesson is very complicated, it can be overwhelming. So we need some techniques for managing that amount of information. And then lastly, capacity but not use it. So we want to foster generative processing. We want to motivate learners to want to understand the material. And lastly, assessment. This kind of just is lets us know what the learner knows. It lets us know the knowledge that the learner has acquired. We have to start with a learning objective. So in any lesson, we want to state what is the change that we want. And the typical ways comes are retention tests that essentially measure ability to recall or recognize the information, and transfer tests, which focus on being able to use the information in a new way or in a new situation. In my research, I'm focusing on transfer as the main dependent measure because that is really the hallmark of understanding. We want to make sure that the learners understand the material. So let me give you an example here. This is just a very short explanation of how a bicycle tire pump works. So we could have a voice say when the handle is pulled up, the piston moves up, and so on. That works, but most people can remember a little bit of that, but they can't really perform very well on a transfer test. If we add graphics, in this case, an animation that kind of shows what's going on with the bicycle tire pump in sync with the narration, we can create a multimedia presentation. So these are kind of screenshots from the animation that go along with the words. And then we can give a test that measures retention by asking people just to write down what they can remember. We can have a transfer test where we ask people to explain, to redesign make it more effective, or we can give them a troubleshooting question to ask them, why is it not working? Conceptual question like, why does air enter the pump? Where they have to kind of invent the idea of difference in air pressure. So these are ways of trying to measure and transfer that are a thing we use in our research. We know that signatures of learning outcomes, poor performance transfer, which is no learning. We see that too often. Rote learning, where you have good performance on retention, but poor on transfer. So what we're trying to do in this research is compare how the learning outcomes, or really the transfer test performance, when we present a standard lesson versus the exact same lesson with one feature added. So if you show the next slide, it gives you kind of a graphic of what I'm talking about. So one group gets the standard lesson, one group gets the enhanced lesson, which just has one feature added to it, like maybe the instructor is smiling when she's giving her lecture versus not smiling. Then we give them a transfer test, and we want to compute effect size by just looking at the difference between the mean scores divided by the standard deviation. That tells us how many standard deviations better does the enhanced group do compared to the control group. I'm looking for any effect size greater than 0.4 because that is an educationally relevant difference that's important. It's kind of the consensus, I think, from people like Hattie and others who have done a lot of intervention studies. So let's look at the next slide. You can go on past this one. Go to the next one. This is results from 9 different experiments that we've done that look at comparing transfer test performance with a lesson that has words and graphics, which is the black bar, versus just words alone, which is the white bar. The y-axis is percent correct on a transfer test, and you can see that people do a lot better on a transfer test if we're able to if we're able to add graphics along with the words. So this we call multimedia principle. This is kind of what got me started in this whole field. There's a real power to adding graphics to words, but not all graphics are equally helpful. Not all multimedia messages are equally effective. So in the rest of this talk, I just want to share with you techniques for how we can combine words and graphics to produce meaningful learning. So please go to the next slide. Kind of the rest of the talk, I want to focus on evidence-based principles for designing effective multimedia instruction. So let's go to the next slide. So we've conducted over 200 experiments where we compare a control, kind of a standard lesson to the same lesson with one feature added. We're looking for effect sizes on transfer tests greater than 0.4. So let me share with you the principles. So let's go on to the next slide. And go ahead to the next one. So these are techniques for trying to reduce extraneous processing. So just to get rid of that wasted processing, the first technique is coherence, which is basically, let's get rid of the wasted or the unneeded material in our lesson. So any graphics that aren't really directly relevant to the instructional objective, any words that aren't, we want to weed those out. So let's look at the next slide. This comes from a lesson on how a virus causes a cold. It has 5 or 6 steps to it. So so these are kind of slides from just one of the steps. On the left, we've added interesting but irrelevant facts about viruses that I put in red here. In the lesson, they weren't in red. Based on pre-testing with our our University of California students, they found this to be a really interesting fact about the study in Pennsylvania showed that it has to do with the role of engaging in sex and viruses. So they thought that was interesting. So we added that in. The version on the right is exactly the same, but without those what are called seductive details, interesting but irrelevant facts. People do much better without the seductive details, even though you might think making things more interesting would get people more involved. That's not really the case. So if we look at the next slide, it shows us the coherence principle in 18 out of 19 experimental tests. with a median effect size of 0.86. People do better when we get rid of the extraneous material. Next slide, please. Next one is signaling. If we can't get rid of the extraneous material, at least we can highlight the important material. So let's look at the next slide. So this comes from a lesson on how neural transmission works. It's a little animated lesson. It's in Chinese, so I can't really tell you exactly what's going on here. It's with colleagues that in China that we work with. And the version on the left, as the on-screen agent is talking, she just stands still. She's not pointing anything. She's just explaining really 13 steps in this process. In the version on the right, she's using a pointer to point to the part of the graphic she's talking about as she talks about each step. People do much better in the signaled version on the right because it's easier to connect the words with the graphic. You don't have to, your eyes don't have to scan all around. They know where to look. So let's look at the next slide. In 26 out of 28 studies with a median effect size of 0.7, people learn better when we highlight the important information in a lesson. And if it's something like that animation, it should be in sync with the voice of the instructor. Let's look at the next slide. Go ahead to the next one. So you might think it's a good idea if we have a narrated animation like the one on the left. This explains how lightning storms develop. You might think it's a good idea to also add on-screen text so people can choose between whether they rather listen or read. So the version on the right has narration and on-screen text. But the problem with that is if you're reading the caption, you can't be watching the animation. If you're watching the animation, you can't be reading the caption. So you might lose some information. So the redundancy principle is it's not useful to add captions to a narrated animation. Let's go to the next slide. So in 8 out of 12 tests, it's not helpful, but there are certain boundary conditions, like when you're learning in a second language, it's useful to have the printed words. If there's a lot of technical jargon, if it's and if you just use short amount of text, it's okay. Okay, so let's look at the next slide. Another way to reduce extraneous processing is spatial contiguity. So let's look at that slide. The next slide. So here's a lesson on how a car's braking system works. On the left, there's a caption at the bottom and the illustrations on the top. The captions explain step by step what's going on, and the illustrations show you what happens before and after you step on the brake pedal. Are you hearing me okay? Is everything going okay? Okay, good. On the version on the right, we've taken the words and placed them next to the part of the graphic that they're talking about. So that's an integrated presentation. This reduces extraneous processing because you don't have to scan between the caption at the bottom and try to find where in the illustration you should be looking. This shows you where you should be looking, so it reduces the amount of wasted scanning, visual scanning, and it helps you connect the words with the part of the graphic. So if you go to the next slide, you can see that putting the words next to the part of the graphic they're talking about greatly enhances learning with an effect size of 0.82 on transfer tests in 9 out of 9 experiments that we ran. And the kind of last way to improve or to reduce extraneous processing is on the next slide. The temporal contiguity principle. So let's look at the next slide. On the left, if we have, for example, this lesson on how lightning storms develop, it runs for about 2.5 minutes. On the left, we can run the animation and then the narration. So you get 5 minutes of presentation, or we can first have the narration, then the animation. We call that successive presentation. That results in very poor learning. The version on the right the words and the graphics are simultaneous. They're in conjunction with each other. So as the voice is talking about an updraft, the animation shows an updraft. So if we go to the next slide, you can see that temporal contiguity, having the words and graphics at the same time, results in much better learning with an effect size greater than 1 standard deviation on transfer in 8 out of 8 tests. So if we go to the next slide, it just kind of summarizes all of these. Coherence, signaling, redundancy, spatial contiguity, and temporal contiguity. So now let's move on. And let's say we figured out a way to reduce extraneous processing, but we have a very complicated lesson for the learner. It still overloads their working memory because it's so complicated. What can we do? So let's go to the next slide. One thing we can do is break the lesson down into smaller parts. I call that segmenting. So let's go to the next slide. Here's, again, the lesson on how lightning storms develop. On the left, it's a continuous presentation. It just runs for 2.5 minutes. It has 16 different steps in it. Cool, moist air moves over a warmer surface and becomes heated. That's the first step. In the version on the right, the lesson stops after each of the 16 little segments. And then there's a little continue button that the learner can click on to go on. So basically you get about 10 or 15 seconds of the lesson. It has one big idea. You make sure you understand that. You click on continue and you go on to the next one. So on the version of the right, you have control over the pacing of the lesson. It's broken into 16 little parts, and you can just make sure you understand one part before you go on. So let's go on to the next slide. This is a slightly different way to do segmenting. It comes from a lesson on geographic information systems that's used in geography courses. On the left, we have one whole slide that has just a lot of information on it. It's pretty overwhelming for most learners. On the version of on the right, we break it into 3 parts. So first you can get the first third on the top, then we add the second part, then we add the third part. And you can control that with your mouse so that you can make sure you get one part before the next part gets added to the slide and the next part. So let's go on to the next slide. This is just another way to do it. So let's go on to the next one. In 7 out of 7 experiments with an effect size of 0.67, it looks like to me, segmenting has a positive effect on transfer test performance. So we're not really changing the lesson. We're just breaking it down into parts and progressively adding on so that people are not overwhelmed by all the information that's on the screen. Okay, so segmenting is one way to deal with a complicated lesson. Let's look at the next slide. This is another way. Pre-training. This involves making sure learners understand the names and the characteristics of the key elements in the lesson before we try to explain how they all relate to each other. So let's look at the next slide. Here's a lesson on a car's braking system. On the left, we have a narrated animation that explains you step on the brake pedal, the piston moves forward in the master cylinder, and so on. On the version on the right, before you get that, you get a little pre-training where you can click on any part of the braking system, like the piston, for example. Then that is spotlighted, and it shows the piston moving forward and backward and says, this is the piston in the master cylinder. It can move forward or back, so that you learn what all the technical words mean, like piston. A lot of people don't even know what that means. So you're getting pre-training in what the main elements in the system are. When you get that before the lesson, it kind of reduces your cognitive load as you're watching the lesson, because when you hear a word like piston, you already know what it means. You don't have to try to figure it out. So let's look at the next slide. It shows us in 10 out of 10 experiments, people learn better if we provide some training in the names and characteristics of the main concepts before the lesson, with a median effect size of 0.78. which is a large effect size. And lastly, for managing essential processing, we have the modality principle. This is the idea that people learn better if the words are spoken rather than printed. On the left, we have the lightning lesson with narration. On the right, we have it as with captions or annotation. The problem with the version on the right is that it creates split attention. As I mentioned before, if you're reading the caption, you can't be looking at the animation. So you're kind of overloading the visual channel. With the version on the left, we've offloaded the words onto the verbal channel so that you can process the words through one channel and the images through another. We've effectively increased your processing capacity. So let's look at the next slide. In 18 out of 19 experiments with a median effect size of 1, we see evidence for the modality effect. Although this has been the most studied and most controversial of my principles, there are boundary conditions. It doesn't apply when the words are unfamiliar, when they're in your second language. It's better for them to be printed. Or when the lesson is slow-paced or controlled by the learner, it doesn't matter. All right, so the next slide kind of summarizes these 3 techniques for managing essential processing. And let's move on to the next major task. If we have reduced extraneous processing and we've managed essential processing, now the learner has cognitive capacity maybe to process the material more deeply, to try to make sense out of it. They still might not do that because they're not motivated. So how do we foster generative processing? How do we get people to want to make sense out of the material? Because many students don't feel that's their job. They feel their job is to just listen. This is kind of the newest set of work that's been done in multimedia learning. Let me start with the personalization principle. So the idea here is we want to change the wording from formal wording to more conversational wording. So in the version on the left, this is from a lesson on the human respiratory system. It says, during inhaling, the diaphragm moves down, creating more space for the lungs and so on. And there's a screenshot from our animation. You can see we're not very good artists. Sorry about that. And I put the in red. It wasn't in red in the lesson, and it's spoken, but I just wanted to show you where the thes are. We changed all the thes to your. So during inhaling, your diaphragm moves down, creating more space for your lungs. We did that in many different places throughout the lesson, trying to create a more conversational lesson and also probably self-reference. So now this feels more like it's about your body, so maybe you'll be more motivated to understand it. So let's look at the next slide. In 13 out of 15 tests with a very large effect size of 1, we see people do better on a transfer test when we put the words in conversational style rather than formal style. This doesn't seem to apply maybe to higher achieving learners, but for beginners, which are most of the learners we deal with, conversational language is helpful. So using first and second person like I and you and we and us, rather than using always just formal scientific third person wording, seems to help people learn better. When we first got this finding, I didn't believe it. I asked my graduate student, Roxana Moreno, to replicate it. She did like 5 times. She got the same result. So I'm beginning to believe this one. Let's look at the next one. Embodiment. This is a little bit weirder. So let's kind of look at the next slide to give you an example. What I mean by embodiment is that when we communicate, we not only use words and images, but also our whole body is part of the communication package, both in presenting information and also in receiving it. So I don't know if you can see me now, but I'm gesturing as I talk. So that's part of my presentation, I guess. What we're looking at here is a lesson on building an electrical circuit. On the left, it's filmed from a third-person perspective, the way most YouTube videos are done. On the right, it's the exact same lesson, the same voice, the same hands, the same movements, but we've just filmed it from a first-person perspective with the camera like over the shoulder of the instructor. And maybe it kind of feels like that's your hands that are doing it. So there might be some self-reference here. Let's look at the next slide, a slightly different version of embodiment. Here we have a lesson, a video lesson, where Celeste here is explaining what is this? The Doppler effect. On the left, the figures are already drawn. On the right, she's drawing as she lectures. She's using the exact same script, same illustrations. It's just whether she's drawing while she's talking or not. The version on the right is more embodied. You might feel like it's your hand that's drawing. So there might be some self-reference there. Let's look at the next slide. In this case, we're trying to work with eye contact. In the version on the left, the instructor is explaining how kidneys work, but she's only facing the board or the side of the room, never having eye contact with the audience. On the right, we're using what's called a transparent board, where you can look at the audience, and even as you're writing on the board, and there's a computer system that transcribes things so that the mirror image makes it look correct. So she can have more eye contact on the right. So if we look at the next slide, you can see that when we have a more embodied presentation, like a first-person perspective or eye contact or drawing as you're lecturing, in 16 out of 17 tests, people do better on a transfer test with a median effect size of 0.58. So embodiment is just an emerging idea in cognitive science, and we just tried to capitalize on it in a few different ways here. Let's look at the next one. Another way to do this is just through voice. Voice conveys a lot of social information. So let's go to the next slide. If we have, let's say, the lightning lesson, we can have it spoken by a pleasant human voice, or on the right, that's on the right. On the left, it's spoken by an unappealing voice. In most of our studies, that's a computer synthesized voice from kind of the older synthesizers that weren't 100% human sounding. So you can tell it's kind of a machine voice. You can understand it, but it's machine-like. Let's look at the next slide. This shows us that in 5 out of 6 tests, people learn better from an appealing human voice with an effect size of 0.74. Today's synthesizers might be better, so the machine voice issue might not be as important, but that remains an open question. Let's go to the next slide. How am I doing for time? Oops, got to speed up. Positivity principle. Let's look at that one. So here the idea is students learn better when instructors display positive gestures and facial expression. On the left, the instructor is kind of has a angry kind of facial expression. She has her hands crossed across her body, which is also kind of a negative gesture. She's kind of leaning back, which also is negative. So she's kind of conveying a negative emotional vibe, even though the lecture itself is on binomial probability. When she gives this lecture on the right, it's the exact same slides, the same script, but now she's a positive instructor. She smiles, she has outward gestures, she's leaning forward. She's actually a student in our in our theater department who did an amazing job in creating these videos. So let's look at what happens when we look at the actual transfer test results from the negative and positive instructor. In 3 out of 4 tests, people do better when the instructor has positive emotional tone than negative. We're getting a smaller effect size than I would like, just 0.34, but we're kind of working on this one, which we call the positivity principle. And we actually have more recent studies that we just finished that we're able to produce a stronger effect. So I think this is an interesting idea that we just want to study a little more. Let's look at the next one. Emotional design. So this, if we look at the next slide, the idea is what we want to do is on the version on the left, this is a graphic from the lesson on how a virus causes a cold. On the right, we have made it into color. We're using appealing colors for the virus and the host cell. We're giving the virus and host cell facial expressions. The virus has a fierce one. The host cell has a kind of surprising one, which is in line with the consistent with the storyline. So we call that, I guess, emotional design, because we're trying to elicit a kind of positive feeling about the lesson through the way we design the characters in the lesson. If we go to the next slide, you can see this is taking the lightning lesson and using characters from the Disney movie Frozen to also kind of create emotional design. Let's go to the next slide. In 4 out of 4 tests that we ran, we're getting a fairly decent effect size of 0.57 of implementing emotional design in our lesson. And lastly, let's look at the last design principle, generative activity. So all the things we've looked at so far, the learner's pretty passive. With generative activity, the learner actually has to do something. So this is from a lesson on greenhouse gases. It has 4 little animations to it. On the version on the left, you just go through those 4 animations. You don't have to do anything. You just watch it. On the right, it stops after each of the 4 sections, and we ask the learner to please type in a 1-sentence explanation of what they just learned. So there's just a little bit of activity on the part of the learner. We call that a generative learning activity, in this case, self-explaining, writing an explanation of what you just saw in 4 different, after each of the 4 sections. And if we go to the next slide, you can see that we've run a lot of studies with generative learning activities, 44, and in 37 of those, we're getting positive effects on transfer. Overall, a median effect size of 0.71 when we ask people to do things like write an explanation during pauses in a lesson. So generative activities, learning activities can be really effective. The next slide just kind of summarizes. And the next one also summarizes. And if you just go through the next few slides, let's see, you can just keep going through, Noah. Let's see, yeah, just keep on going. Keep going. Yeah, just keep on going. We can go back to these if we want to. Just one more. So this is part of the team that helped create this, so I just wanted to put them on the screen. We are trying to continue from here to look at learning in immersive virtual reality, game-based learning, learning with on-screen pedagogical agents, and also just kind of shoring up these principles. And the next slide just gives you some reference material. So thanks for your attention. Thanks for getting me through our technical difficulties, and I'm glad to answer any questions.
So thank you so much, Richard, for a very stimulating talk. We will now move to the Q&A session. If anyone in the audience would like to ask a question, please raise your virtual hand. And there was also a question in the chat. Tzvi is the one who asked, so yeah.
Yes. two things that maybe have changed in the last few years and might be relevant is first that because of generative AI tools generating multimedia, it started with images and now even video is much easier. It's not necessarily good quality, but it gets better all the time. So even a single teacher can generate multimedia very easily, which might be good or might be overused. And at the same time, it seems there's a lot of complaints or indications that the young generation sometimes doesn't respond so well to text, but respond very strongly to videos and images. So how do these two things maybe affect the future of multimedia use in teaching?
Oh, you've kind of touched on everything we're thinking about for the future. That's a really great question. So just in terms of generative AI, I think all of us in our field are trying to figure out how is AI going to affect education? And also, how can I get a grant that involves AI? I think we're all trying to think about that too. So we all know it's going to have a tremendous effect, but it's kind of hard at this point to see where it's going, but we definitely want to, I think, do more research on generative AI. If we're going to create lessons with AI, I think we have to teach it my principles so it knows to design it based on principles, which is a feasible thing to do. I personally am more interested in AI as maybe as a tutor, that you could have your own personal on-screen tutor. We could have a pedagogical agent on the screen that's generated through AI. You could ask it anything you want and it could work with you. So it's like having your own teacher there 24/7. That's definitely doable right now. So I think it's all very exciting. We just don't know where it's going. It's a huge, for me personally, a huge research area. And I also agree with you about text versus video. I don't really think it's necessarily a great idea to give up on text, because text is this is the way we communicate from one generation to the next. And students need to know how to comprehend text and how to study text and how to make sense out of text. So I wouldn't give up on that, but I have been doing a lot of research on video, and video is misleading because I think you're right. It seems like it's easier, but it's maybe harder to learn from because it seems so easy. I don't think you put in as much effort and you might miss the point. So I think we need to design video in a way that is going to make sure people pay attention to the relevant material, that they interact with it, maybe by having pauses and where you have to have a generative learning activity. So I just have a book coming out called Teaching with Instructional Video, where I try to talk about that. How can we design video that's going to actually be instructionally helpful? Thank you for your question.
Thank you very much.
Any other questions? Esti?
Yeah, thank you. Just a question about VR. If the principles that you presented here, which some of them were looked into many years ago, if they all translate into VR the same or they change, so that's.
Yeah, I think that is a great question too. I think we've got to just check that out, because things like one study we've just done is on emotional design in VR, where we try to make things more exciting, like what's this? A lesson on the phases of the moon, and you can move things around, and when you move them around, they have little sparkles that occur as you're moving them. That actually doesn't help. So I'm thinking maybe emotional design might not be needed in VR, because VR already is so emotionally engaging. We don't need to try to add to that. It may be distracting. I think the issue with VR is it can be distracting because it's so visually overwhelming to people. And a lot of them, it's the first time they've been in VR. So it's emotionally arousing. So some of these techniques might not quite work exactly the same way. So I do think we've got to work on which ones do and which ones don't. We have a handbook that's coming out. That's with MIT Press on research on instructional design principles for VR. It's a edited book. So that's coming out hopefully within the next few months, where we try to deal with the issue you're talking about.
Any other questions?
I have a question.
Marina?
First, thank you very much for enlightening presentation. I'd like to ask about related to learning as it's changed and what the learner knows, and the selecting, the integration, and you didn't relate to the constructing part, that like knowledge building or the active part of the learner in active learning environments. So, and this relates also to the AI era, where we see that learner, also adult learners, students, are not doing the integration, like they become more passive.
Yes.
But there is also a premise of being more active, like creating softwares with vibe coding. And so if you can relate to this passive active part in learning.
Sure. I think that's a really great question too. I think I started out in this research focusing just on what I would call instructional messages. So they seem passive. An instructional message, which could be, a slideshow presentation, a video, an animation, where it's just presented on a screen and you watch it. So that's what I call an instructional message. And on the face of it, the learner's passive because you're just sitting there. So the real challenge is, how can you prime cognitive activity with a passive medium? So that a lot of the work I'm presenting kind of fits that mold. You have what seems like a passive situation, but how can we prime cognitive activity? Because it's not necessarily behavioral activity that causes learning. It's cognitive activity. We want people to construct new knowledge in their working memory. They have to select what's important. They have to mentally manipulate it and create a structure, and then they have to figure out what prior knowledge to use to integrate with it. That's the construction process. That's what we're trying to prime. So I think I focused a lot on that. But usually when people talk about active learning, they're talking about the learner being active physically. And that can also lead to cognitive activity, but it doesn't necessarily. You can engage in hands-on activity that doesn't really make you think. So we want hands-on activities or generative activities that are going to promote deeper learning. So I think that's where our research on learning strategies or generative learning strategies comes in. We can do a lot of these things in classrooms, have people have discussions, projects, things like that, which are hopefully going to create not only behavioral activity, but cognitive activity. So that's more on the side of that early slide I showed of teaching learning strategies, or at least getting students to engage in learning activities. So I think these are two ways of trying to promote deeper learning. One is just through good instructional design. One is through designing actual activities that are going to promote deep learning. Does that make sense?
Yeah. It's like learning environments that actually combine the instructional design and the environment, which is like the third learner in the environment is also part of it.
Yeah, that's a good way to say it.
So Ina, you wanted to ask a question?
Yes, I could see that you conducted a lot of research during the years, about multimedia learning and textual compared to textual learning. Nowadays, generative AI can produce very easily audio learning materials, and I wonder whether your group is doing some kind of research on instructional, conversational audio materials, and what multimedia principles can be applied to these kind of materials, how we can use instructional design principles to make audio learning better.
Oh, thanks for that question. Yeah, it's something we're all thinking about, and we talk a lot about in my lab. We've conducted a few studies, because we're not experts on the technology side of it, so all this kind of research has to be kind of a team effort with people from all different fields to make this work. So we've kind of developed a collaboration with people at Purdue University, and we're starting to design studies along the lines that you're talking about. I kind of think the same principles are going to apply even when we have AI involved in the instruction, but it gives us much more opportunity for learners to interact with AI. To me, that's the most interesting thing I want to study, like you're mentioning, just the conversations back and forth. How should you design those? What's the most productive way to do that? Because I think, how much structure should there be? Those are all issues. We already know a lot from just expert tutoring about what expert tutors do, and in a way, we kind of want AI to be like an expert tutor. So I think it's a fascinating research area. I'm looking forward to doing more of it. So yeah.
Any last, Orit?
Okay, so it's very important to me to listen your opinion, because your model is very basic in education and for me too. So you insert a lot of a few emotional characteristics for your principles, like that the lecture will be with a positive gesture, like smile, or to keep about motivation for learning to the learner. But I want to ask you about a social characteristic, like the interaction between the teacher to the learner, or if the learner sit in a class between him to other learners, like if the teacher say to the learner one positive word during the lesson, so if it affect about his learning process, of if one of the students tell to the other student good one words during the learning session, if it's affect the learning process.
Yeah. Well, I think that's a great issue. It's been studied a bit. We should probably well, it's been studied a lot in the area of motivation. What is the effect of the student-teacher interaction? So yeah, I think sometimes praise can be helpful because it could create a positive affect, but praise when it's just general and it's really not deserved, and you just say good job even when they didn't do a good job, or you don't really give too much information about why it was a good job, it might not be as helpful. It can backfire sometimes, I think. So I think we have to think about what is the best way for a teacher to interact with the students. Sometimes it's better to let them struggle for a while and let them come up with a good answer rather than trying to, quote, help them with it, because that conveys the idea that you don't really think they can do it, so that might reduce their self-efficacy. So I think we have to think about what the effect of what the teacher is saying, what effect that has on the students' self-efficacy or their motivation. It's kind of a little bit out of my field, but I do think you raise a really important point. We want a positive atmosphere in the class, but I think if it's artificial, it might not be that helpful, because if we're going to try and give feedback, we want to tell what about their performance that was good, what did they do that was good, rather than just say good job, I guess. Does that make sense? Sure.
So, any other questions? Okay, so let us thank our keynote speaker once again. Thank you, Richard, for a fascinating keynote and an enriching discussion. And thank you to all of our participants who have stayed with us at this late hour. We're looking forward to see you all at the conference tomorrow. Registration starts at 9, and our opening session featuring Professor Baruch Schwartz starts at 9:30. And we will also have a post-conference Zoom session on Wednesday evening featuring another keynote by Professor Roger Azevedo, so we're hoping to see you there as well. Thank you, everyone, and good night. Thank you again, Richard.
It was my
Thank
pleasure.
you.
Thanks for all the.
Thank you so
Thanks for
much.
inviting me.